All right, logarithms part 1. To start us off, to see what a logarithm actually is, we're going to start off with something you already know, a nice little exponential function. So suppose we had a little function something like this. F of x equals 10 to the x. Now suppose you wanted to try to find the inverse. So you went, I want to get the inverse of this thing. So you go, okay, no problem. Remember, this was actually just like a y. So every y becomes an x, and every x becomes a y. So I go, yep, this is the new inverse of that function. But what we try to do normally is, now that we've swapped out the x's and the y's, we try to get it to be y equals. Well, here's where we run into a problem. How are you going to rearrange this to get that y sort of on the ground? There's no way to do that. So what we do instead is we go, hey, why don't we just take the same relationship and give it a new name and just say, you know what, that is a logarithmic function. Now these two things here, okay, this guy up here and this thing down here, they mean exactly the same thing. Okay, this is the more understandable way of writing it, but this is writing it as y equals. Oh, and by the way, in case you're wondering where this 10 is, normally it's right, well, it's right here. But typically when it's the 10, it's not written. This is called common logarithm when it is a base 10. And so it's often left out. All right, now let's get into some sort of nitty-gritty here. Now that we know kind of what a logarithmic function is, and what it actually is just the inverse of a related exponential function. So let's get to the nitty-gritty. There's really two forms here. So I'm going to start by showing you a form that I think you should memorize, because I find it very helpful so I can bounce from one form to the other. So suppose somebody comes along and says, I want to work this out. Okay? This you could even do on your calculator. You would get 2 as your answer. But to understand what that actually means, okay, I like to do this. You take the base of your logarithm, and then the number that the whole thing equals, the 2 in other words, is your exponent. You see, it's the same relationship as 10 squared equals 100. And what we've done here is we've just written it in a different way. But what you want to be able to do is bounce from one form to the other form. Now remember, that's exactly what we had before. Remember I said this. We said, oh yeah, y equals log base 10 of x. That's another way of writing, and we had, and I'll write it in this version here, 10 to the y equals x. Okay, this is exactly what we had before. I really think, I'm going to put a star next to it, if you memorize this, because it's kind of easy to remember, log of 100, base 10, equals 2 is the same as saying 10 squared equals 100. It allows you, kind of guides you to the one form and the other form. And remember, they're saying the same thing. It's just a different new way of writing it. If you keep that form in mind, it makes it pretty easy to answer some of the questions then. So let me just do some examples here, and I'll show you how I'm going to bounce from one form to the other, and then it's really not as bad as it looks. Like, suppose you had this, log of 32 base 2, and you're trying to figure out what this equals. Okay? In this logarithmic form, I find it's difficult to follow and understand what's going on. So I'm going to rewrite it, just like I've taken this information and rewritten it here on the right. I'm going to write this as, yeah, the 2 is the base. It's kind of like the 10 was up here. And the 10 ends up as the base of the exponent. So this time it's the 2. And then it became 10 squared. So 10 there's where the 2 is. Now, that's what I'm looking for, so I don't know what that is. So I'm just going to put the question mark there. And then it equals, well, where's this 100 going? That's like the 32, and that just goes on the right. So now I look at it, and I go, oh, so 2 to the something has to equal 32. So actually, the something that we're looking for is 5. Okay? But in this form, it's easy to see what it equals. And in the logarithmic form, just because it's new for us, it's a little bit trickier. So let's throw another one at you. See how we're doing for time. Oh, we're good. Okay, so let's do a couple more of these. Let's do a, let's see, log of 125, and it's base 5. We want to see, well, what does that equal? Okay. Now, you can choose to write it in this form, or a lot of students go, and they just get used to this, and they read it as 5 to the something has to equal 125. Okay, again, I'm just mentally bouncing from one version to the other version. 5 to the something equals 125. So then I look at it and I go, oh, that's got to be a 3. Yeah, there it is. So I just worked it out by kind of thinking my way through this a little bit easier version or form of the same statement. All right, let's try some that are a little bit slipperier, like maybe we had log of 1/10. Okay, and notice I didn't even write the base. It says, what does that equal? Well, this is obviously a common logarithm because no base was written. And that means it's base 10. So that means what I'm looking for is the base of 10, 10 raised to the something, and that has to equal 1/10. Now, whenever I see this has to become a fraction or a smaller number, I know that, oh, my exponent must be negative. Hey, maybe it's -1. Let me see if that works. 10 to the -1 is like 1 over 10 to the +1. Well, by golly, that equals 1/10. So I know that this equals -1. Okay? And we're ready for my next example. What if the base of my logarithm wasn't a whole number? What if it was something like 1/3? What's that going to do? Okay, no big deal. I'm going to go to the other form so I can analyze it more easily. This says 1/3 to some exponent, so 1/3 to some exponent has to equal 27. All right. So again, I'm thinking, oh, I think we're talking negative exponent here, because the negative exponent would mean this gets flipped. And what I want to do is flip it over so it's a 3, and then I know I want to turn my exponent positive. So I'm sort of thinking, fishing around 3 cubed, I know that equals 27. So what exponent would I need in here? I'm thinking maybe -3. Because it's a negative exponent, I would have flipped the 1/3 to make it 3. Then I would have turned my negative exponent positive. Yeah, that looks like it's going to work. So by inspection, I think the answer is -3. All right. I think that's probably a good place to stop, and it was a good introduction to logarithms. Just as a final tip, remember, bounce back to the easier to analyze exponential version of this logarithmic statement, and then usually they're pretty easy to kind of unravel. So that's where we'll stop.